Welcome to Teja Statistics. In this class, we are going to learn about the problems. Okay, problems on multiplication theorem of probability. Let's see. What is this question contains? A bag contains four red balls and five black balls. If two balls are drawn in a successive method, then find the probability that they are with the red. If the drawn ball at first draw was replaced and not replaced. Let's see the solution for this. The drawn ball is replaced before the second draw. Let ABA be the drawing a red ball at first draw and B be the drawing a red ball at the second draw. So here the total number of balls are 4 plus 5, so that is 9, and the red balls are 4. Okay, what is n value for n for an event A? For an event A, the capital N value, or we can say that uh, total number of outcomes or possible outcomes are n is equals to nc 9c1, that is 9, and m is the favorable cases of values of the red ball. Drawing a red ball, how many red balls we have here is that is 4 4c1. So probability of A is equals to m divided by n, that is 4 divided by 9. For B, event B, n is equals to 9c1. Okay, here we are before going to take the second draw, we are replacing the ball into that box again. Okay, so that's why the total number of balls will be the same. So 9c1 again, and the favorable cases are also be the same. Probability of B for the second draw is also be the 4 divided by 9. The probability of drawing balls are red, okay, are said to be, that is probability of A intersection B in a independent draws. So probability of A into probability of B, 4 divided by 9 into 4 divided by 9, we got the probability value as 16 divided by 81. Okay, next, the drawn ball is not replaced before the second draw. Okay, this is very important. So here one is event is occurring before going to the second draw. Let A be drawing a red ball at first draw, and let B be the drawing a red ball at the second draw after the red ball is drawn at first draw. So for event A, probability, or we can able to calculate by same calculation, the total number of balls are 9 and the red balls are 4. You can see here, that is 4 divided by 9 again, and probability of B given A. Before going to consider the second draw, here the B given A, that is A is already happened. So n is equals to 8c1, that is 8, m is equals to 3c1, that is equals to 3. So the ball is not replaced. Here the total number of balls are reduced, that is minus 1, 88. Okay, next, the red balls also be the reduced, that is 4 minus 1, that is 3. So 3 divided by 8. The probability of two red balls are in successive draws, that should be explained in a conditional probability formula. Probability of A into probability of B given A. So this is 4 divided by 9 into 3 divided by 8. So total probability of A intersection B, the two balls are should be in successive method, that is 1 divided by 6. Very important problem. Next, a box contains 8 red balls and 5 white balls. Two successive balls or 3 balls are made at random. So find the probability that the first 3 balls are white and the second three are red. When there is a replacement, when there is no replacement. Similar question. So very important. So that's why we are discussing again and again. So the probability that the first draw will be the white is given by probability of A is equals to 5C3 divided by 13C3. What is this 13C3? The total number of values from that balls. From that we are drawing 3 balls in the first draw. So the 5 will be the white. Okay. The probability that the second draw will be the red. Probability of B is equals to 8 C3 divided by 13 C3. Events being independent of each other, the probability of their compound event is probability of A intersection B is equals to probability of A into probability of B. So that is 5C3 divided by 13C3 into probability of 8C3 divided by 13C3. So the probability value is 0.002. So when there is no replacement here, the probability that the first first 3 balls will be the white, that is again the probability will be the same. The probability that the second draw there will be 3 red balls with no replacement, that is probability of B given A, again it is reduced. Okay, that is 13 minus 3. Okay, 10 C3. Okay, అదేవిధంగా ఇక్కడ 8. Okay, so probability of events being independent from the probability of their compound event is probability of A intersection B is equals to probability of A into probability of B given A. Hence we got the probability value as probability of A intersection B value as 0.016. Next, the 3 students are selected at random, one after from a class consisting of 12 boys and 8 girls. Find the probability that 3 students are to be girls. Let A be the selecting a first girl and B given A be the selecting the girl of after the first selection. C given A intersection B selecting a girl after second selection. Okay, so probability of A is equals to 8C1 divided by 20C1. Probability of B given A, so one girl is already selected, so 7C1 divided by 19C1, and 2 girls are already selected, so the number of girls are 6C1 divided by 18C1. So we got the multiplication theorem. By using multiplication theorem of the probability of A intersection B intersection C is equals to probability of A into probability of B given A into probability of C given A intersection B. Then we have the values of A given 8 divided by 20 into 7 divided by 19 into 6 divided by 18. So 14 divided by 285. This is how we got these calculations. Next problem will be on this again. A problem is given to the 3 students A, B, C, whose chances of solving it are 1 by 2, 3 by 4 and 1 by 4 respectively. What is the probability that the problem will be solved if all of them try independently? Let the events A, comma B and C are solving the problem by the students A, comma B and C respectively. Given that probability of A is equals to 1 by 2, probability of B is equals to 3 by 4, probability of C is equals to 1 by 4. if at least one student solve the problem, then the problem is said to be solved. We have to calculate the probability of A union B union C. So independent events, there is no common point. So probability of A plus probability of B and probability of C plus that is independent events, probability of A into probability of B minus probability of B into probability of C minus, and so on like that. If you substitute that values, then you will get the total value as 29 divided by 32. Okay. You have another method of solving also. What is the probability of not solving the problem? A bar intersection B bar intersection C bar. So they are independent also. 1 minus P of A into 1 minus P of B into 1 minus P of C. So you got 3 divided by 32, that is A union B union C is equals to 1 minus this. So 1 minus 3 divided by 32 is equals to 29 divided by 32. Very very important methods for the first years and independent problems also. I am giving another question on this. Okay, please do it as your own. Okay. Two aeroplanes hit a target in successive. The probability of each correctly hitting the target are 0.3 and 0.2 respectively. The second will hit the target is the first uh, misses the target. Find the probability that target is hit, both fail to hit the target. Okay. Thank you. Thanks for learning from Teja Statistics. Please do subscribe.